As many of those who know me would agree, I'm something of a scientist myself. My name is Ryan Chang, and growing up around science has been a huge part of my identity. From the giant ambassadors of Sagan and Tyson, to the smaller creators of Muller and Rober, I've always championed the internet as a technological wonder over a technological woe. And trust me, I've seen my fair share of technological woe.
I specifically remember growing up in the virtual laboratory mostly. Channels like Nile Red and Cody's Lab have been a huge inspiration to me, presenting the wonderful world of chemistry and the marvels it can produce. Over my high school years, though, I started to realize that I could actually understand some of the scientific jargon and the ways these videos and articles use. I started to think, hey, I could actually do some of the stuff in this post.
With this newfound knowledge and confidence in hand, I started away like those fake Pinterest life hacks nobody actually does. But this year, I decided to walk my walk and see if I actually could replicate the experiments that I saw online. What would I find and explore throughout my journey, following after the steps of my inspirations? In case you haven't noticed, that was my essential question, Miss Peelstone, so you can tick that legal box off. Okay, thank you. Yo, how many times is your mic gonna change? My first task was to find what procedure to do. Of course, being quite amateur, I had to stay away from the extremely dangerous chemicals, difficult procedures, and complex knowledge, and make sure I could reasonably stay safe. Looking at you, Cody's Lab.
Nice.
After a bit of searching, I decided to try extracting the sourness out of lemons. In other words, citric acid. It seemed to be the right mix of feasibility and a challenge. And with the lemons purchased, let's begin. Now, most chemical extractions and procedures at the most basic level come down to reaction and separation. For example, take magnesium carbonate, also known as gym chalk. No, not the blackboard chalk, that's calcium carbonate, totally different. After some back-of-the-napkin calculation, we put baking soda, the common name for sodium bicarbonate, over heat and watch it decompose into water vapor, carbon dioxide, and sodium carbonate. Once the bubbling stops, the reaction is done. Unfortunately, my camera is too much of a potato to capture any sort of nuance. However, it does detect infrared, which explains the weird purple alien glow. But trust me when I say there were tons of little geysers venting out CO2 all over the place. Luckily, the water and CO2 have already boiled away thanks to the heat, so the separation step is already achieved. So next, we'll dissolve magnesium sulfate heptahydrate, also known as Epsom salt, with equal moles of our sodium carbonate in solution. Brief aside to Chem 11 and 12, remember that all our ions are now just floating in the solvent water loosely. All of the chemicals in our equation are insoluble, except for magnesium carbonate. Now, whenever a magnesium ion and a carbonate ion collide, they'll react to form a molecule that will precipitate out of this white solid. Once the reaction is done, we can filter off the remaining liquid and set the white powder to dry. We now have some chalk perfect for gymnastics or rock climbing, and to think it came from 2 household products. The same idea will come to play now with the lemons, only it'll be a bit more complex. Alright, here we go. Firstly, we need to get the juice out of these lemons. A long, tedious, arduous process that is finally done. Yeah, hooray for the power of time-lapse. The citric acid is somewhere in here, but so is a lot of other junk, like organic compounds and colorants. But now, it's time to get fancy, so it's off to the lab we go. Big thanks to Miss Mac for letting me use the space and equipment during flex time, as well as some of the new reagents, such as sodium hydroxide, also known as lye. Here's the thinking. Rather than take all the other junk away, it's much easier to take the citric acid out and refine it. So adding basic sodium hydroxide to the acidic citric acid will cause me a neutralization reaction, turning the 2 into a sodium citrate salt. Now that we have our solution, it's time to drop it out. We need to get the solution to about a pH of 9, which will occur once the solution turns orange. Now that our sodium citrate is made, we can start to filter out the rest of the stuff in there. Now the filters were a bit on the smaller side of what I was expecting, which means I had to use quite a lot of them, but I got this awesome distillery shot as a result, so there are trade-offs. The next day I came back, and after a couple of passes, my filtrate was ready for the next step, so we press on. The next step in the procedure is to swap out the sodium citrate for calcium dicitrate. This is so we can further refine the citric acid derivative and help in our future step. Luckily, the calcium chloride solids came in pellets instead of literal stone, so it was much easier to dissolve them into water. I measured out the correct amount and poured it into solution. Of course, if we look back to reaction kinetics, we know that reactions speed up with heat, so over the hot plate it goes and now we wait. Right now, the sodium citrate is reacting with the calcium chloride to form tricalcium dicitrate and sodium chloride, the latter being soluble in water, but the former precipitating out into this opaque sludge. You can actually see the precipitate pulled away from the liquid as it falls to the bottom, but filters will speed this up, so more filters we shall use. Now that I have the calcium dicitrate extracted from the other junk, it was time to put it back to its original form. We'll do this by using sulfuric acid. The result of these two chemicals mixing will be calcium sulfate, which is insoluble, and citric acid, which is, and we will filter out later. This explains why we need to convert the sodium citrate into calcium citrate, as sodium sulfate is also soluble in water, which is unhelpful. Chemical extractions are all about the difference between two products. That being said, however, we kind of have a problem. Okay. Yeah, if it wasn't clear already, I record these on separate days. Get over it already. You see, the calcium citrate I have is, well, minus impurities, should be a white powder. Calcium sulfate is also a white powder. You see the problem? Unlike the trisodium citrate reaction, which was quite obvious when it was done, we won't be able to tell when this reaction is done. An excess of sulfuric acid will leave some vitriol behind unreacted, but adding too little will destroy our yield even more than it already has been already. Somehow, we need to add the exact amount of acid needed and know it ahead of time. I think this calls for some stoichiometry. Though it may be the bane of every Chem 11 student, stoichiometry is a useful way that chemists can accurately predict the amounts that certain chemicals will react together, as well as which item will be limiting and in excess. In this calculation, I weighed out my sample and found I had 45.29 grams of calcium citrate tetrahydrate. I include the hydrates this time because it will factor into the molar mass. Calcium citrate tetrahydrate has a molar mass of 570.49 grams per mole, and we will multiply that by the mole bridge of 3 moles of sulfuric acid per each mole of calcium citrate. We can get this ratio from the equation that I showed last slide. Finally, we are going to be using 3 molar sulfuric acid, so for every 1,000 milliliters, there will be 3 moles in that solution. Notice that I'm only adding about 95% of the sulfuric acid I actually need. This is because an excess of sulfuric acid will be very hard to purify out of the final product, but an excess of calcium citrate will be very easy to just filter. Therefore, we want to make sure that our limiting factor is the sulfuric acid. Once we crunch the numbers, we can find out that we need precisely 75.42 milliliters of sulfuric acid. Alright, enough math. Let's get back to science. Ryan from the future here. Please excuse my scream of agony while I yell in anguish of losing 2 minutes of footage because of a misclick. What you doing? Working feverishly to fix a mistake I made despite being crushed under the weight of an emotional hydraulic press. I see. But wouldn't it be more wise to just jump straight back into action to recover instead of spending literal needless hours making a technically impressive but kinda unnecessary joke? Out. Yes, sir. Yeah, this was in no way worth it for one small joke. The mixture was a bit sludgy, so I slowly added some more water in. Sulfuric acid has a tendency to boil when added to water, and that is very, very not good. I mixed it thoroughly around, and when I was sure that the reaction was finished, back to the filters we go. This time, the citric acid is dissolved in the water, so we want to keep the liquid. And after a couple days, it was extracted. And now, for the longest and most tedious task. We have the citric acid, but it's dissolved in a ton of water. So to get it to recrystallize out, first we need to boil off most of the water. And once the acid is super saturated, it'll crystallize out. Now the school hot plates are okay, but not the most efficient. I spend most of my flex periods at time literally watching a pot boil while doing homework in the lab. But after hours of boiling over multiple days, I got the amount down from about 500 milliliters to around 70 milliliters. The liquid was definitely more discolored when I boiled the water off, but we'll talk about that later. So with the water wicked away, I poured the contents into a dish in the fume hood and let it evaporate. After some progress checks, I was left with the final product. Now, packaged citric acid you can buy at the store is a pure crystalline white. The source video I got the procedure off of had their product a bit discolored. My product was looking less like a Sprite and more like a dark shade of Nestea. But honestly, that was okay. Though my yield was kinda abysmal and my product impure, I need to remember that 1. This is my first time trying anything like this. 2. I was working with school chemicals and school equipment. And 3. I'm just a senior, graduating from an East Van public school. I mean, I was recording all this on the front-facing camera of my laptop because I didn't have the right photography equipment. I may be able to explain most of the steps with high school knowledge, but there's still a vast amount of things that I don't know about, but we'll learn later on. I think the main issue was adding a bit too much sodium hydroxide in the beginning. I wanted to make sure that the reaction was completely done, but I think I ended up discoloring the compounds more than they needed to be. I also skimped out on the amount of filter passes I need to do because I kind of felt a bit pressed for time and didn't want to overstay my welcome in the lab. Fun fact, I initially planned for this procedure to take only 2 days. But with all that being said, I'm still glad that I proved that I really could do the things I grew up in awe of, and Well, the results speak for themselves. This was the largest chunk I could recover, and you can hopefully see it's composed of many other smaller cubic crystals. There were some other stragglers that didn't make it onto the big chunk, and here are some strange outliers that grew a bit differently to the rest. Again, not sure why, but here they are. Let's get a final shot of that big chunk now. Ah, there it is, shimmering in the light. Nice. On a side note, the solids in the past filtering actually hardened into calcium sulfate, also known by its mineral name gypsum. It's quite literally as hard as a rock once it dried. After all, it was used as a sort of ancient mortar for buildings in the old times, so if any of you geology nerds want a sample, then hit me up. Overall, this experience was quite an ordeal that I would have never pulled out without the looming threat of, not graduating high school. And that's not to discount the hours of work away from the lab researching chemical properties, formulas, precautions, and waste disposal. The MSDS was definitely my most frequently visited page during the peak of this research. I often found myself technically working on my project in the strangest of times, just for a few minutes that turned to a few hours. Miss Fieldstone, although my log is sporadic, you gotta trust me when I say I definitely spent way more than 30 hours on this project that I just couldn't be bothered to write down. It's 2 a.m. But I have afternoon class. Oh my goodness, it's 5 a.m. Well, hey, 30 hours is 30 hours, right? So, what did I learn? Number 1, plan for everything. Even with all the prep I've done, I did still have a couple blind spots in my planning. The way to account for that is just to prepare for anything. Have all the PPE gear on and prepare for the worst. Number 2, experience is valuable. I would have no doubt that things would have been faster, better, and more efficient the second time around, and even more so the third. Unfortunately, this being just a fine side project, I didn't have the resources available, but not all is lost, because even this tiny experience can lead to future growth in future projects completely unrelated, so to call it a waste would be quite misleading. And number 3, life isn't perfect. With the quality of resources and experience I had at me at the time, I was happy to just get results at all. To think I could reproduce outcomes akin to industrial graded gear and professional wisdom is insane. So though I still aim for perfection, this was yet another example of not to see the end of the rainbow, ever distancing as it is, but to focus on the local and improve one step from yesterday. So, lab report conclusion? The results displayed a positive intake in experience and entertainment from this escapade, and though perhaps not today, in the future, a version of me possessing the intelligence and wisdom of the inspirations I once looked up to is surely in sight as I head to university and continue my findings. If this is what 18-year-old me could do, then my adult me has a high launch pad to take off from. Thank you. Holy cow, what was that lisping, dude? You really gotta slow down your talking. Jeez, you thought you could fit this under 10 minutes. Yeah, right.